let's remember what we were doing last time, which was Monday. What we were doing was taking one big fraction and figuring out how to break it down into a sum of two or more fractions. And we decided that if the denominator was linear, the numerator had to be constant. If the denominator was quadratic, what would the numerator have to be? Linear. Right. So let's take a look at number 6. And remember, the first thing you want to do is factor your denominator as much as you can. So how would we factor that denominator? Yeah, and that's not really factoring it, is it? That's just writing it out. So we're going to leave it this way. There's no factoring that can be done. So it's 8x cubed plus 13x over x squared plus 2 quantity squared. Now, I need you to think about this. How many factors do you have in this denominator? What are they? X squared plus 2 and x squared plus 2. So you have 2, but they're the same. Now, when you have 2 factors or more factors that are the same, here's the way you have to do your denominators. You're going to do that factor to the first power. You're going to do that factor to the second power. And if that was an exponent of 4, you do it to the third power and to the fourth power. Did we talk about that a little bit last time? Okay. Now look at your factor, x squared plus 2. Is that factor linear, quadratic, cubic? Quadratic. And remember, the degree of the numerator must be 1 less than the denominator. Good. So in this case, it has to be linear. So the way we're going to write it is ax plus b. You have to have every term represented from where you start all the way down to a constant. Now let's look at the second. It's still quadratic. Don't worry about the raised to the second power. You're just looking at the x squared plus 2. That's quadratic. Your numerator still has to be linear. Cx plus d. Now your textbook does stuff like a sub 1x plus a sub 2, and I just hate that. So we use a, b, c, d. Okay, that's the hard part right there. Do you remember what we did after this? Good. We're going to multiply by the common denominator, which is x squared plus 2, quantity squared. Who wrote free day on my clean board? I did. Really? No, it's not happening. Now remember, we're going to distribute here, and here, and here. When we multiply by far left, everything cancels out, so I'm left with 8x cubed plus 13x. What about when I distribute to here? Good. I have my ax plus b times x squared plus 2. Last, it's just plus cx plus d. Good. What do you think? Good. We're going to go ahead and multiply this out. Why did I write what? Here? That's a D. That's CX plus D, just done badly. That's a D. It's all right. What do you want to do on the right side of the equation? You bet. So we're going to kind of group our like terms. So let's try to do this in some organized manner. AX to the third plus BX squared. Good. If we factor out an X, that'll be 2A plus C. Yep, plus 2B plus D. Okay, so we don't see this right now. Yo, you don't have it, do you? Oh. So what? A is 8. Good. A is 8. What's B? Why is B 0? Because there's no X squared on the left. Good. You said 2A plus C was equal to what? 13. What's C? Negative 3, because A is 8. What's 2B plus D? 2B plus D is 0. What's D? Yep. D is 0, so this is 0 plus D equals 0. You all right? So, what is our answer? 8x cubed plus 13x over x squared plus 2 quantity squared equals. Yep. A is 8 and B is 0. And negative 3x plus 0. And there's your answer right there. Okay, you were much more calm about this than you were Monday. I hope that's a good thing. You have accepted your fate. Oh. Oh. Questions? Okay. Now there's one problem I want you to write on your paper, because I realized there wasn't one like this. X cubed minus 2 over x squared plus x. Think about that one for just a moment. What's the degree of the numerator? Well, yep. Degree of the numerator is bigger than the degree of the denominator, so what? Yeah. Yeah, and Eve, I already saw Eve's reaction to realizing we had to do long division. This one's not as long as the last one we did, though, is it? But it's still long division. Put placeholders in for anything that doesn't appear. Yeah, it's a whole lot better if you do that. All right, let's do this. X cubed divided by x squared. First divided by first, that's x. What do I do with that x? Multiply it by x squared plus x. And I heard subtract, which means change the signs. What do we do now? Good. Bring down. First divided by first. Second. Negative 1. Negative 1 times x squared plus x. What now? Subtract, which means change the signs. Good. Bring down. That's the remainder, x minus 2. So we're going to write this thing down as x minus 1 plus what? That's right, x minus 2 over x squared plus x. Now all we've done so far is long division. We haven't done a partial fraction decomposition yet. But we only have to do that on what part? On the fraction part. So let's do that on the fraction part. That's not what I wanted. X minus 2 over x squared plus x. How do I do a partial fraction on that? Good. We're going to factor that denominator with a GCF. Good. I've got 2 factors in the denominator, so I'm going to have 2 fractions. What are the numerators going to be? Constants. Good. This is first come, first serve. I will give anybody 2 extra credit points if you go to the board and work it. Right there. Okay. Malin is going to work this problem. Malin is going to, no, she has to get it right. Malin's going to work this problem. Hang on, Malin.
You want me to talk it?
Just talk. Yes, I want you to talk it.
Okay, so first you have to do this, and you then multiply it by the common denominator of x plus 1.
Yeah, it's having seizures again. Okay.
Okay, so okay. So then you have a x plus 1 and b x. And then it's x minus 2 equals, and then plus bx.
Back up just a minute, Malin. Any questions here? Is she good? A times x plus 1 plus b times x. Yep, go.
Okay, and then x minus 2 equals ax plus a plus bx. And then x minus 2 equals a plus b x plus a. And then a plus b equals 1 and a equals negative 2. So b equals 3. And so then it's x minus 2 x squared plus x equals negative 2 over x plus 3 over x plus 1.
Yeah, what's the 1 left off?
The x minus 1 part.
So put your plus x minus 1 on the other side as well. There you go. That's it. Well done. Perfect. Now you guys did really well. Do you have any questions? Go ahead. Go ahead, Sarah. She just didn't write the original problem, which was this right here. Yeah, yeah. So if you write that equals the x plus 1 and blah, blah, blah. Yeah. Question? Huh? Yes, absolutely. Absolutely. Now, I heard one comment of, I cried trying to do these problems. Are you feeling better?
No, I'm still gonna cry, but it's okay. I cried up there too.
Lindsay just asked a really good question. If I can get the board to cooperate, I'll show you the really good question she asked. If you have you have one, don't you? Tell me what it is. Okay, so if you right now, remember when the denominator was x squared minus 2 quantity squared, we had to do x squared minus 2 and we had to do x squared minus 2 quantity squared, right? We're going to have to do exactly the same thing with this. I need you to think it as x minus 0 or x plus 0. So it would be x and then x squared and then x minus 3. But let's talk about what your numerator would be. So you'd have an x squared, and an x minus 3. What's your numerator going to be on this one? A constant. What's your numerator going to be on this one? A constant. Yeah, and I'll hold off on a minute, but it's a constant. Now, what's your numerator going to be on this one? Be careful. It's not linear. Because you are thinking it like it's something like x minus 0. And this factor right here is linear. So that numerator will be a constant. So this is going to be b, and this is going to be c. Remember, when it was x squared, oh, fiddle. If it's x minus 2 quantity cubed, you're going to have x minus 2, and you're going to have x minus 2 quantity squared, and you're going to have x minus 2 quantity cubed. You have to treat x squared the same way you would treat that. So it's x and x squared and x cubed if that's how far you need to go. I'm glad you asked that question. Difference quotient. What in the world is a difference quotient? I wrote that myself. Well, that's what a quotient is the answer to a division problem. And this does have something to do with division. All right. One of the most basic definitions in calculus uses this difference quotient. So you're going to work with it a whole lot when you take calculus next year. Yes. Yes, you are too. If you are a junior, you're going to be in my calculus class. Yes, you are. Now, I wrote these notes myself just thinking about, I think this is going to be, I hope this is going to be pretty easy for you. All right. I drew a function, and I'm going to call that function f of x. Now, what I'm going to do is I'm going to pick a point. Right there. And I'm going to call it x. Now, if I go up from there, then I have a point on the curve. And the coordinates of that point, anybody know what the coordinates of that point would be? X, f of x. Because isn't f of x just another name for y? Now, I'm going to go over some. How far? H far. And I've got another x value. What's that x value? No, hang on. The x value is x plus h. So, what are the coordinates of that point right there? X plus h, f of x plus h. Have I lost you yet? Almost. Now, what we're going to do is we are going to find the slope of that line right there. How do you find slope? Rise over run. We just started these. Rise over run, but we're not going to talk rise over run. What's the formula for finding slope? Well, that's the slope-intercept form of a line. Okay, do you really not know that? Y2 minus Y1 over X2 minus X1? Rise over, to find the rise, you subtract the Y values. Yeah. And to find the run, you subtract the X values. Yeah, but I'm not always going to give you a way to count the boxes. You'll make them yourself. What is the slope of this line? Y2 minus Y1 over X2 minus X1. So, Y2 minus Y1 over X2 minus X1. How will the denominator simplify? It's just h, right? Because x minus x is 0. Don't make this harder than it is. What did you just find? The slope. You didn't find h. You found the slope of that line, right? Now, that line has a special name. That is called a secant line. It's called a secant line because it intersects that curve in 2 points. Now, you're saying it intersects more than 2. I know, but that's not an issue. What we did is we found 2 points on that curve, and we found the slope of that line. That's called a secant line. So what you just found is the slope of the secant line. You have to know that little formula right there. F of x plus h minus f of x over h. Can you say it? F of x plus h minus f of x over h. Oh my gosh. Try it again. F of x plus h minus f of x over h. Know it. To learn that? No. Yeah, I don't have a song. So, what is the definition of a difference quotient? F of x plus h minus f of x over h, which is the slope of the secant line to a curve. Now, all we're going to do is that formula. That's all we're going to do, okay? But I want to give you a little taste of calculus, all right? What we'll talk about in calculus is this. What if I make h smaller? What if I made h just be this big? Then your other point is going to be there, right? So when I find the slope of my secant line is right there. Make sense? What if I made h even smaller still? What if I made h big? Then there's the point, and the slope of the secant line, the line looks like this. What am I doing to h? How small can I make it? I can make this thing infinitely small, which means that h will be so close to 0 that you cannot tell the difference. When h is so small that you cannot tell the difference between h and 0, where is that point x plus h? Let me back up. If I keep making that h smaller and smaller and smaller, then this point, x plus h, f of x plus h, is going to get real close to what? X f of x. So they're going to look like the same point. They're going to be so close together. And so what happens is this. Here's your x. What happens is that secant line then becomes a line that only touches that graph once. And that's called a tangent line. That is the foundation of calculus right there. You're getting sleepy on me. All right. You don't need to know that now. All right. I believe that what we have is 1, 2, 3, 4. We have 4 questions to do together, and then you have 4 questions to do. All right? Now we're going to back up way back to probably like 7th grade. Middle school was a bad year. What wasn't middle school? Missed a lot of school? Okay. Pretend that we have not done any of this other stuff. F of x equals x squared. What's f of 1? What's f of 3? 9. What's f of negative 2? 4. What's f of a? A squared. What's f of r? R squared. What's f of h? What's f of x plus h? Will you please remember how you just did that? What did you do? You substituted x plus h everywhere you saw an x. That's all we're going to do. That's all we're going to do. Now look at the instructions here. I got some of you who are going to sleep, and I'm sorry I'm boring you to death. I do not mean to. We're going to apply that difference quotient to 4 functions. Let's start with number 1. We've got a function f of x equal 2x minus 3. What's that look like? If we graphed it, linear, Y-intercept is -3. Slope is 2. Good. Now, what we are going to do is we are going to apply the difference quotient to that function. So, what is, if f of x is 2x minus 3, what is f of x plus h? 2. Do you buy that? Everywhere here that I saw an x, what did I put in its place? An x plus h. So f of x plus h is going to be 2 times x plus h minus 3. Minus f of x. What's f of x? But I'm subtracting the whole thing all over h. Do algebra 2 it, simplify it. Okay, simplify that numerator. Okay, if you can't simplify that numerator, we got a problem. Come on. Now, folks, at this step right here, if you don't have stuff that adds up to give you 0, you have made a mistake. So this is 2h over h, which is 2. That's it. Done.
So, what did you just find?
We found, we applied the difference quotient. Now, again, what can we do with that? In pre-cal, not a darn thing.
Okay, makes sense.
But when you get to calculus, I'm going to expect you to already know how to use the difference quotient so that we can jump into our calculus and learn derivatives. Okay, which is awesome. Which is awesome.
Yeah.
It is. After you do homework and quiz and test on it, no. You won't do difference quotient anymore this year. All right, let's try the second one. Oh, by the way, look at this. And look at this. What do you see? Oh, when that function's linear, you're going to get the slope. Goodness. Oh my goodness. Okay, second one. Why? Take calculus and you'll find out. I love calculus. Calculus rocks. Okay, here we go. Apply the difference quotient. What is f of x plus h? Everywhere I see an x, what am I going to put in its place? X plus h. So this is going to be x plus h squared. So it's f of x plus h minus f of x. But what's f of x? All over h. Now we're going to clean it up. Can you do x plus h quantity squared in your head? Good. If you can, do it. If you can't, write it out and FOIL it. Tell me if there's something you're not understanding. What's the matter? Did you do this? Then if it looks like mine, it's right. Then you can cancel. And when you get to this step, if there's not something you can cancel, then you've got a mistake. So what we've got now is 2xh plus h squared divided by h. Can we simplify that any further? How? Factor out an h as a GCF. This is the only way you can cancel an h, all right? 2x plus h. Okay. We're doing pretty good. Okay. You ready to go to the back? We got 2 more. We're going to apply the difference quotient. F of x plus h. Wherever I see x, what am I going to put in its place? X plus h. So how many places am I going to put in x plus h? 2, here and here. Are you getting that for f of x plus h? Everywhere I saw an x, I put an x plus h. What?
So you're going to do all of that?
Minus f of x. And if I got to minus all of that, I got to put it in parentheses. All over h. Yeah, a lot of people, you're going to be so worried about getting f of x plus h right, you're going to forget to do the f of x part. Now it's a matter of cleaning it up. You getting here? What's the matter? X plus h times x plus h. It's going to give me x squared plus 2xh plus h squared if you FOIL it out. Once you get here, you better have quite a bit of stuff that's going to add up to give you 0. X squared minus x squared, negative 4x plus 4x, positive 7 minus 7. Now that's what you're left with. Yep. Factor out that h. Two x plus h minus. Do you have any questions? Are you finished with this one? Yes, no, I don't know, you're judge, I don't know. Okay. Another teaser for calculus is I will teach you in calculus how to look at that and not have to do any of the work and figure out what the answer is. How? 3 seconds. Nope. Nope. Take calculus. Well, then take Cal 1 as a freshman in college.
But it won't be with you.
That's true, dang it. One more. You won't want to do that. You won't want to do that. All right. Aha. Okay, now Eve's already having a fit. Because we're going to have a complex fraction. All right. F of x plus h minus f of x over h. You want to look in your numerator and figure out what is the common denominator. Yeah, cool, you can do it. You can do it. What's the common denominator of 1 over x plus h quantity squared minus 1 over x squared? X plus h quantity squared times x squared. Just multiply them together. What is this fraction right here missing? What's that fraction missing? Now let's talk about what all that numerator mess is. Here, what have we got? We got x squared minus. Over all over. It looks ugly before it gets better. Do you have questions at this point? Don't go any farther. Get here, and then let me remind you of something. How do you do 2/3 divided by 5? So it's 2/3 times 1/5, right? Right? Now, how do I divide by h? Multiply by 1 over h. So if I multiply the top by 1, I get the top, right? And if I multiply the bottom by h, then I just multiply the bottom by h. And now look at this. It's not a complex fraction anymore. Clean up the numerator. Are you okay so far? Now I'm going to look to see if I've got stuff that'll cancel, and if I don't, I've screwed up. Let's see if we can save ourselves a step. Look at what I've got left in the numerator. Negative 2xh minus h squared. Let's go ahead and factor out the h. So it's going to be h times what can I do now? One more thing. Can't I factor out those h's? And that h just being multiplied by that parentheses crap. And this h down here is just being multiplied by this other crap. So I can factor them out. Negative 2x minus h over x squared times x plus h quantity squared. And that is your answer. Yeah. Sarah. Now, what you have is 4 problems to practice. You're going to do these 4. So your assignment is to finish your partial fractions and do these 4. Okay? And will I take these up when you have your last quiz thing? Yes, sure will. A separate piece of paper. Yeah, separate piece of paper, please.